Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to this first lecture on electrochemistry. From this lecture onwards, we will discuss different topics as per your syllabus in the class 12 NCERT syllabus. So in this lecture we will discuss the introduction, the very fundamental things in electrochemistry. So let us write the heading of this lecture, that is Introduction to Electrochemistry. Today we are going to discuss some basics in the electrochemistry, and afterwards we will discuss different topics related to your syllabus. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, let us understand what do we mean by electrochemistry. Electrochemistry is basically a branch of chemistry which deals with the relationship with the electrical energy and chemical energy that released from a spontaneous redox reaction. Now question arises, how we can convert this chemical energy into the electrical energy, and that is basically an arrangement by which we can do that. That is called the electrochemical cell or galvanic cell or voltaic cell. So we can write this is so the first aspect of the electrochemistry, that is a conversion from the chemical energy to the electrical energy, and the arrangement is called the electrochemical cell, or we can say this is a galvanic cell, or we can say this is the voltaic cell. Another aspect, the second aspect of the electrochemistry that we are going to deal with, that is how we can utilize the electrical energy to bring about the redox reaction, which is otherwise non-spontaneous reaction. So by using the electrical energy, we will carry out the non-spontaneous chemical reaction, and that is the another aspect of the electrochemistry, that is we can write conversion. But the process is called the electrolysis. So we understand electrochemistry deals with these two very important aspects. One, that is the chemical energy to the electrical energy, and the arrangement is called the electrochemical cell or galvanic cell or voltaic cell. Another aspect, that is the conversion from the electrical energy to the chemical energy. In this way, by utilizing the electrical energy, we will bring about the redox reaction, which is otherwise non-spontaneous. And this is this arrangement by which we can do that, that is flowing the electrical energy, flowing the electric current to a solutions. We can able to disintegrate it into the different substances. It is called, the process is called the electrolysis, and the arrangement is called the electrolytic cell. So two cells that we are basically deals with in this electrochemistry chapter, that is the electrochemical cell or voltaic cell or galvanic cell, and another that is again very important in terms of industrial practices, that is the how electrochemistry going to help us in our day-to-day life, that will by the electrolytic cells, and the process is called the electrolysis. So two aspects that is we are going to deal with in this electrochemistry chapter. Now in this lecture we will discuss in detail about electrochemical cells, or we can say galvanic cell or voltaic cell. So let us understand. Today we will understand the galvanic cell. What is galvanic cell? First let us understand. Galvanic cell is basically a electrochemical cell which converts the chemical energy into the electrical energy. Chemical energy that is the energy released from a spontaneous redox reaction, which will be converted into the electrical energy. And the galvanic cell, we will understand how this electrical energy has been converted into the chemical energy is converted into the electrical energy. This is the arrangement. How this arrangement has been done by the use of different reactions, redox reactions, that we will discuss in this lecture. So this is the galvanic cell, which is basically a electrochemical cell, and there is a Gibbs energy that we understand when a chemical reaction is spontaneous, like your redox reaction. What is there? There is a energy associated with this reaction. This is called the Gibbs energy. This is called Gibbs energy, and this Gibbs energy will convert into the Gibbs energy of the redox reaction. We can write Gibbs energy of redox reaction. Redox. We know what is redox reaction. That is basically reduction and oxidation reaction that has been combined, because these reactions are simultaneously occurred. That is why it is called the redox reaction. And you can, if you want to know details about this redox reaction, you can see my lecture on this, the redox reaction. What we have to do? We have to type the times with Mukherjee sir in the YouTube, and you will find the playlist. In the playlist you will find the redox reaction chapter, that is a videos related to this, and you can go through this. So Gibbs energy of redox reaction, Gibbs energy of redox reaction has been converted into the electrical energy. This energy is capable of doing some work, and this work is being converted into the electrical energy, and that we understand how this chemical energy has been converted into the electrical energy with the use of a proper arrangement. This is called the galvanic cell, or we can say it is the voltaic cell, or it is basically electrochemical cells. So we now understand it. So now we are going to discuss the galvanic cell. Galvanic cell. Galvanic cell is basically a electrochemical cell that you understand, and one of the example of this galvanic cell is Daniel cell. Daniel cell. Oh, baby. One of the example is Daniel cell. Daniel cell use this redox reaction for conversion of the chemical energy into the electrical energy, and this redox reaction is this: zinc solid plus CO2 plus aqueous, and it will produce Zn plus 2 aqueous and Cu solid. This is the redox reaction that is used in the Daniel cell for conversion of the chemical energy into the electrical energy. And how we do that? The arrangement of this is like this. This is a typical diagram of the Daniell cell. You can see that is basically Daniell cell is having the two portions. In one portion we will put the zinc rod in the zinc sulfate solution. In this case, zinc rod is called the anode. This is called also anode. Here you can see this redox reaction that we have written here can be splitted into the two reactions. That is, first, that is the oxidation reaction, that we know zinc lose electron and it will become the zinc plus 2 aqueous ion and it will liberate 2 electron, and this 2 electron will be accepted by the copper plus 2 ion which is in the aqueous solution, and it will become and it will accept this 2 electron and it will become the copper metal. So these two reactions, this reaction is going on here and this reaction will going on here. This is basically we call, this is the total cell. This is a Daniell cell is basically a galvanic cell, and this total cell has been divided into two portions. In one portion you will see there is an oxidation of the zinc rod. It will become the zinc plus 2 ion, and this is called, here the oxidation is going on. We can write here oxidation is going on. Oxidation. And here is a second reaction, second half reaction is going on, that is the reduction half reaction. Here copper rod with the copper sulfate solutions. Copper rod with copper sulfate solution, it will, here you can see that is the reduction is going on. Here is reduction is going on. Reduction is going on means the zinc has been, zinc plus 2 will accept that electron which is released by the zinc rod, and zinc rod will melt as a zinc plus 2 ion. So what is going to happen? How the electron flows, that we are going to understand now. How electron going to flows, that is again a very important thing. You can see here the zinc rod, there is basically the two tendencies. You can see this is a, you will call the zinc rod is a electrode. This is called the anode. It is one electrode, and it is another electrode. This is cathode, and this is anode. What is going to happen? Just understand. That is in the interface. This is the zinc rod and this is the solutions. That is the zinc sulfate solutions. And in this interface, you will find there is a two tendencies. Metal ion wants to go to the metal electrode surface by making the metal positively charged. And another tendency that we can observe, that from the electrode the metal atoms wants to go to the solution as ions by leaving the electrons, and this tendency will put the electrode in the negative charge condition. So let us understand what is happening here. In the zinc you can see it has a higher tendency of losing the electrons. So what will do? It will lose electron, it will give back here in the zinc rod, and that is why it will leave the zinc rod as negative ion. This will be, zinc rod will be in the negative ion, negatively charged as compared to the electrolyte ZnSO4. So it is negatively charged. Now what is going to happen in case of this electrode, that is the cathode? What is going to happen? Now copper ion, Cu2 plus ion, it will take the electrons from this metal rod, on this electrode, that is copper, and it will make this electrode copper is positively charged. So we can understand with this tendency of these ions and the metal ions, it will leave this electrode as positive. As positive here, in case of copper you can see the positively charged, as with respect to the solution, then this solution we call it is a electrolyte, and for this it will become positively charged and zinc rod is negatively charged, and this is called the potential difference between the electrodes and the electrolytes. Here you can see negatively, it is negative potential we can say. For the zinc rod we will call it is a negative potential, and for this rod we will call the positive potential, or it is called the oxidation potential, or we will call here it is a reduction potential. But by convention we will always have to take into consider the reduction potential, not the oxidation potential, that we will discuss in detail. So what is going to happen with this when we arrange like this way, zinc in the zinc sulfate solution and copper in the copper sulfate solution? What is going to happen? There is a potential created in the zinc rod and in the copper rod, and this is called the electrode potential. That is a very, very important thing that to understand, the electrode potential. Electrode potential. This is called the electrode potential, that is been occurred here due to these tendencies, different type of tendencies of the metal ions and the metals. Metal ions in the electrolyte solutions and the metal atom in the electrode. So at the interface of the electrode and the electrolyte, we will observe there is a charge developed. Different types of the charge developed, that depends on the tendencies of the ions. That in some case what we observe, the metal atom wants to go to the solution as metal ion. At that time what we find, that it will leave the electrons there and it will be negatively charged. And the another case, the metal ion we want to be deposited on the electrode surface, and it will become the positively charged, because it will taking the electrons from the metal, and by taking the electron it will be reduced and it will become deposited in the electrode surface. So there is a potential you can observe, that is called the electrode potential, and we have to always consider, as per the IUPAC convention, IUPAC rule, that you have to always consider the reduction potential. You have to always consider the reduction potential. That is, the reduction potential means the equation will be like this. That you have to always see these equations for the reduction potential. So that point potential has been created. Now what we will do, if we joint these two electrodes with some metal wire, this is a metal wire, and there is a switch arrangement and there is a voltmeter to understand whether there is electric current flows or not. At the time when switch on this circuit, what is going to happen? The electron will flow from the zinc rod to the electron will flow from the zinc rod to the copper rod, and as per convention, current will flow from here to here. So now we understand how the arrangement has been made so beautifully and so intelligently, that we utilize the redox reaction. This is basically the redox reaction that basically happen in these two steps, two half cells. This is called the half cells, that is total cell, and one of these compartment, this is one half cell and this is another half cell, and this is in this half cell what is happened, the oxidation is happened, another half cell reduction is happened. So, and this is called the anode, where the oxidation is happened and it is been negative potential has been created here. So we will call that this is the oxidation potential, and this will call the reduction potential, because this reduction is happening here. So this is basically one half cell and this is basically another half cell. So we understand now the how we can able to arrange the redox reaction in such a way that the electron we can utilize. Electron has been flows from one compartment, one cell, one half cell to the other half cell. That means the electron has been indirectly being supplied, so that it will be taken off by the copper. Here in the there is a copper. Though ultimately this flow of electrons we can utilize in different electrical applications, running the motor or switch, lighting the bulb, and different types of applications that we can have with this. So now we understand what is a Daniell cell, and in this Daniell cell, by this way you can use different types of electrodes. Here for the Daniell cell, zinc and copper electrode use, and respective solutions, salt of this metal we have used as an electrolyte. Like this way, different types of combination we can choose. But here is another very important thing. Without this cell is ineffective. This is called the salt bridge. Salt bridge is what? Salt bridge is basically making an electrical connection between these two solutions. It will make an electrical connection without being mixing with each other. And this will make a connection, and basically the circuit, this will call an inner circuit. This is the outer circuit and this is the inner circuit. And when these two circuit is completed, only that time the current will flow. Otherwise not. So we understand this salt bridge is what? Now it is basically composed of it is basically U2. You can see this is the U2, and this is a concentrated solutions of the inert electrolytes like KCl, ammonium nitrate, K2SO4. Why we are taking this? There is another logic behind it, because both the cations and the anions will have the same speed. What is going to happen? This salt bridge you will find the cations will goes from this portion of this cell. You will flow, the cation will flow from here, and here also you can see anion will flow from here to here. So that is how we can able to understand the salt bridge. Salt bridge is basically maintaining the neutrality of the solutions, because when the zinc Zn plus 2 is coming here, what is going to happen? That there is a charge disbalance will happen, and this charge disbalance will be maintained by the salt bridge by migrating the anions, appropriate anions, from one direction to the other directions. So now we understand the electrode potential. That is a very important. Electrode potential is basically the potential developed due to the tendencies of the different type of potential has been achieved. That you can see here, zinc rod have the negative potential, while the copper rod have the positive potential. And when it is being connected with the salt bridge, at the time when we complete the circuit, we switch on this electrical, that is metallic arrangement, it will going to flow, the current is going to flow from here. So that is, you can understand the electrolysis. This is the electrochemical cell, and this is the function of the Daniell cell of the galvanic cell, and how we understand how the chemical energy has been transformed into the electrical energy. And that is all for today's lecture. So in this lecture, that is an introduction, and we understand how the chemical energy has been transformed into the electrical energy with the help of a very special arrangement of these cells, that is called the half cells. And another thing that we need to understand, that is the redox couple. Redox couple, here you can see the Zn plus 2 and Zn. This is another one redox couple. Another redox couple is Zn plus 2, Cu plus 2 and Cu. This is also called the redox couple. Redox couple is basically the presence of the simultaneously, that is the oxidized state of this substance and the reduced state of the substance. This is called the redox couple. So that is all for today's lecture. In this lecture, we have discussed a very introductory part of this electrochemistry chapter, and next lecture we will discuss the different topics relating to your syllabus. Thank you very much for watching, and if you like this lecture, you can share to your friends. Thank you very much.